Hey guys, this is Miss Jones. I hope everyone's doing well. We are going to do our first set of video notes. Yay! If you hear my dog whining or barking, don't worry. She just doesn't like it when I'm not paying her any attention. So, anyway, today we are going to talk about the scientific method. The scientific method merely refers to a broad framework for studying and learning more about the world around us in a scientific manner. It's not so much a series of absolute, unchangeable steps as it is a guideline to a method that must be used when trying to reach a scientifically acceptable theory about a subject matter. So, today we are going to talk about the 5 main steps. You may hear more steps from other people, but it could be because they take one step and break it into 2. But we are going to talk about the 5 main steps today. So let's get started. Okay, again, the scientific method is a series of steps to follow to answer a question or solve a problem. The scientific method is a series of steps to follow to answer a question or solve a problem. Objective 2 are the 5 steps of the scientific method and what each one of them means. So the steps are: ask a question, form a hypothesis, test your hypothesis and collect data, analyze your data, and then form a conclusion. So when you ask a question, a scientist asks questions based on observations from their surroundings. So scientists are naturally curious about the world. So while many people may pass by a curious phenomenon and not think anything about it, a scientist or a person with a scientific mind takes note of something that they want to investigate further. And so they form an interesting observation so that they can find more out about it to know how the natural phenomenon works. So in the scientific method, a question converts general wonder and interest to a channeled link of thinking and inquiry. So step number 2, which is form a hypothesis, you take an educated guess about what you think the answer is to your question using an if-then statement. So you see the IV and the DV in parentheses? That's independent variable and dependent variable. And we will talk about those a little bit later in the slides. So a hypothesis also is an informed guess as to the possible answers of questions. So a hypothesis may be formed as soon as you have a question, or it may require a great deal of background research and inquiry. The purpose of the hypothesis is not to arrive at the perfect answer to the question, but to provide a direction to further scientific investigation. Sounds fun, huh? Okay, so the 3rd step is to test your hypothesis and collect data. So you're going to test your hypothesis and collect data. So you're going to set up an experiment to test your question. So once a hypothesis has been formed, it must be tested. So that's why you're going to set up the experiment and test your question. This is done by conducting a carefully designed and controlled experiment. The experiment is one of the most important steps in the scientific method. It is used to prove the hypothesis right or wrong and to formulate scientific theories. In order to be accepted as scientific proof of a theory, an experiment must meet certain conditions. It must be controlled. It must test a single variable by keeping all other variables under control, and the experiment must be reproducible so that it can be tested for errors. So the testing of the hypothesis and the collecting of the data is very, very important. Okay? So the next thing you're going to do is you are going to analyze your data. So you're going to look at your data and decide what it tells you about your question. So as the experiment is conducted in the hypothesis, or testing of the hypothesis, it's important to note down the results. In any experiment, it is necessary to conduct several trials to ensure that the results are constant. The experimenter then analyzes all the data and uses it to draw conclusions regarding the strength of the hypothesis. If the data proves the hypothesis correct, the original question is answered. On the other hand, if the data disproves the hypothesis, the scientific inquiry continues by doing research to form a new hypothesis and then conducting an experiment to test it. So this process goes on until a hypothesis can be proven by a scientific experiment. So this could take several, the testing could take several times, and then when you analyze the data, you know if your hypothesis was correct or not. So the fifth step is to form a conclusion. Form a conclusion. Now, you have to decide what answers to your question is and ask what is right or wrong. Do I need to do the experiment again to find out more? So, you are forming a conclusion. So, decide what the answer to your question is and ask, was my hypothesis right or wrong? Do I need to experiment again to find out more? Okay, hope everybody got that. So we are going to move on to objective 3. Oops, sorry. Which is identifying variables. So that's what we were talking about, was the IV and the DV. So that's what we're going to talk about now. So objective 3 is that you can define the independent variable, which is IV, and the dependent variable, which is DV, and find the IV and DV in an experiment. So there are two main types. The independent variable is the variable that is changed by the scientist, the I control variable. So this is something that's changed by the scientist. It's the I control variable. Okay? Now, the dependent variable is, might change because of what the scientist changes, the variable that is being measured. So, when you're looking at an independent variable, it's the values that the scientist systematically changes in order to see what effect the changes have. A well-designed experiment has only one independent variable in order to maintain a fair test. If the experimenter wanted to change 2 or more variables, it would be harder to explain what caused the changes in the experimental results. For example, someone trying to find out how quickly water bubbles could alter the volume of the water or the heating temperature, but not both. So that is one of the reasons why the independent variable is something that you control. So the second type of variable is the dependent variable. This is a variable that might change because of what the scientist changes the variable that is being measured by. So what the experimenter observes to find the effect while an experimenter may have multiple dependent variables, it's often wisest to focus the experiment on one dependent variable so that the relationship between it and the independent variable can be clearly isolated. For example, an experiment could examine how much sugar can dissolve in a set of volume of water at various temperatures. The experimenter systematically alters temperature, the independent variable, to see its effect on the quantity of dissolved sugar, the dependent variable. So, your hypothesis can tell you what your variables are. So, remember, if I drink a Mountain Dew before bed, then I will not sleep very much. So you're going to tell what the hypothesis can do. So which one's the independent variable? So if I drink Mountain Dew before bed, then I will not sleep very much. So my independent variable is drinking Mountain Dew. So my independent variable is drinking Mountain Dew. My dependent variable is the amount of sleep I will get. So if you see, the independent variable is something that you controlled. The dependent variable is something that was controlled by your independent variable. Also, know that if I do not turn in my homework, then my teacher will give me a 0. So the independent variable is I did not turn in my homework. And the dependent variable is I will get a 0. Because the independent variable means what I will do, and the dependent variable is what I will receive from it. So, we're going to do some practice. If I leave all the lights on all day, then my electric bill will be expensive. So, if you leave your lights on all day, then your electric bill will be expensive. So what do you think the independent variable is? Oops, sorry. So answer those 2 questions in your notes, and we will come back and talk about those after this video and when we're in class. So we're going to now talk about hypothesis. So objective 4 is a hypothesis. I can write a hypothesis using an if-then statement and use the words increase and or decrease. So a hypothesis is always an if-then statement. If I do this, then I will have that. So a hypothesis is an educated guess or prediction, and if-then statement that can be tested. So if the independent variable, then you get the dependent variable. So example, the independent variable is the amount of food that I give my cat, and the dependent variable is her weight, cat or dog. And then the dependent variable, is her weight. So if I increase the amount of food I give my dog or cat, which is the independent variable, the part you are controlling, then his or her weight will increase the dependent variable, the part you are measuring, the effect of feeding her a bunch of food. So do you see how the 2 correlate together? If you increase the amount of food, they will gain weight. So now we're going to talk about controls and constants. Okay, so objective 5 is I can define and identify constants and controls in an experiment. A constant is something that scientists make sure is the same throughout the experiment. For example, watering the plants the same amount of water or making sure that you are testing the same person every time is a constant. It's what you're doing the same. So it's the values that do not change either during or between the experiment. Okay? Then you have the control portion of the experiment. This is the part of the experiment that the scientist doesn't change or add the variable to. When you're testing to see if a Miracle-Gro can really increase plant growth, the plant that does not receive the Miracle-Gro is the control. So the control variable is a variable that could change, but the experimenter intentionally keeps it constant in order to more clearly isolate the relationship between the independent variable and the dependent variable. So that's very important to understand the difference between the 2. Okay, so now we're going to go on to Objective 6, which is observation and inference. So observation is the using of your 5 senses to collect data about your surroundings. And an inference is when you make an assumption or prediction about something that you observe. After you make an observation, you usually make an inference about what's going on. So the differences between the two, observation and inference, is observation means the act of carefully watching or examining, whereas inference is termed as an act of deriving rational conclusion from known facts or circumstances. One is subjective and one is objective. Observation is what one perceives, and inference is an explanation or assumption of what one's perceived. Observation is hands-on, whereas inference is second-hand. Observation is a collection of information without questions, whereas inference is taking decisions about collected information. So observation implies that you're monitoring of the subject under the study. You're watching it constantly. Whereas inference implies that you're logically deducting a conclusion by reasoning. So I hope you can understand the differences between the two, and I hope you have enjoyed the video notes. We will talk about the notes in class, and I will see you soon. Bye.